All right, guys, this is day two of our product and quotient rules and using our secant and tangents that we learned about in our last lesson. So one way that they're going to force you to use the product rule is to not even tell you what the actual functions are. So you're going to have to perform the task with function notation, and then they're going to give you enough pieces of information that you can plug in some numbers and get an answer. All right, so we're given this function f of x, which is g of x multiplied by h of x. And we're told to find f prime of 2. Okay, so these are two functions multiplied together, so we're using the products rule. So f prime of, and I'm going to go ahead and plug in 2 for x. So anytime that I would have written an x, I'm just going to write a 2 instead. All right, so the product rule says derivative of the first thing, g prime of 2, multiplied by the second thing, h of 2, plus keep the first thing, g of 2, multiplied by the derivative of the second thing, h prime of 2. All right, and then all of these things over on the right side of our equation should be given to us in the problem so we can find an answer. So g prime of 2 is right there, is negative 4. H of 2 is negative 1. G of 2 is 3. And h prime of 2 is 5. So this ends up being 4 plus 15, which is equal to 19. All right, so there's no getting around using the product rule there because they didn't even give us actual functions that we can do. All right, so that's one AP style question that you could see with the product rule. All right, here are a couple others where they don't give us like a list of information in the problem. Instead, they give us a graph. Okay, so we're going to have to find all of our values from the graph. I would encourage you to try letter A on your own. It works in a very similar fashion to the problem we just did, but you're going to use the graph to find those values. All right, so here's how it works. H prime of 1 is equal to product rule, f prime of 1, g of 1, plus f of 1, g prime of 1. All right, f prime of 1. So f prime is the slope of f. So f is the less bold one. Here's x equals 1. There's the point right there. Okay, so I want the slope of the line that point is lying on. So the slope of this line is up 2 over 1, so it's 2. G of 1, that is the y value of the point on G, and they happen to intersect right here. So they have the same y value of 1, 2, positive 3. F of 1, again, that's the y value of this point, which is 3. And then G prime of 1, so that's the slope of the G graph right here, and it looks like the slope is negative 1. So I end up with 6 minus 3, which is equal to 3. All right, letter B is just going to apply the same logic here, except we're going to use the quotient rule. So K prime of 6 is equal to, all right, low is G of 6, D high, F prime of 6, minus high, F of 6, D low, G prime of 6, all over low, G of 6 squared. All right, so let's find our values from the graph. So x equals 6 is 2, 3, 4, 5. There it is. Here's the point on G. Here's the point on F. F is the less bold. G is the bold one. All right, so G of 6 is 2. It looks like this one's up here at 4. G of 6 is 2. F prime of 6, that's the slope of this line right here. It looks like negative a half. Minus f of 6. That is the y value of this one up here, which is 4. G prime of 6, that's the slope of this line, which is negative 2. All over G of 6, which we already found earlier, was 2 squared. All right, so I think we've got, this will just be negative 1 because the 2's cancel. Negative times a negative is a positive 8. Then we have a 4 on the bottom, so this is 7 over 4. All right, next one. Find the points where the graph of f has a horizontal tangent. All right, so we talked about this in our lessons when we did the power rule. So we know that f has a horizontal tangent when the derivative of f prime, is equal to 0. Okay, so a horizontal tangent, a horizontal line has a slope of 0, and the slope of the function is the derivative. All right, so we're going to use the derivative here. We could do the quotient rule. You could simplify this into like a power rule form. So if you wanted to, you could write it like this: 3x to the negative 1 minus 2x to the negative 2. And then you could use the power rule there. I would recommend actually using the quotient rule because the simplification is going to be a little easier. And this is one you really want to simplify, even though we're treating it kind of like a free response question, because I do have to set it equal to 0 and have to solve it. Okay, so having a simplified form makes that process much easier. All right, so we're going to use the quotient rule. F prime of x is equal to low is x squared, d high is 3, minus high is 3x minus 2, d low is 2x, all over low squared. So I'm going to go ahead and just write that to the fourth power. All right, let's simplify. So I have 3x squared here, minus, distribute, 6x squared, and then distribute and distribute, so plus 4x, all over x to the fourth. Okay, I can combine like terms, negative 3x squared plus 4x over x to the fourth. And then I can, everything's divisible by x. So I get negative 3x plus 4 all over x cubed. All right, so we're looking for places where f prime is equal to 0. So if your f prime is a fraction, f prime is equal to 0 where the numerator is equal to 0. So f prime equals 0 when negative 3x plus 4 is equal to 0. Do a little bit of algebra. X is equal to negative 4 divided by negative 3, positive 4/3. Let me not box that. That's not my answer. That's my x value of my answer, but it did say point or points. So remember that means an x and a y. So I need to plug that number back in to find my y value. So f of 4/3. So that's going to be 3 times 4/3 minus 2 divided by 4/3 squared. All right, so the 3's cancel. 4 minus 2 is 2. And then 4/3 squared is 16 over 9. Multiply by the reciprocal, so 2 times 9 over 16. And then the 2 and the 16 reduce, so you get 9 over 8. All right, and that's my y value. So let's write out our answer as a sentence over here. F has a horizontal tangent line at 4/3, 9/8. And our reason is because f prime is equal to 0 at that point. All right, that'll do it for this lesson. I will see you on the next one.